Here's another example. A plate having an area of 0.6 meter square is sliding down the inclined plane at 30 degrees to the horizontal with a velocity of 0.866 meter per second. There is a cushion of a fluid 1.8 meter square thick between the plane and the plate. Find the viscosity of the fluid if the weight of the plate is 280 Newton. So from here we have that is sliding down and a plate is having an area is sliding down an inclined plane. That's we have something like this sliding down an inclined plane to the horizontal with a velocity of about 0.360 meter. There is a cushion of a fluid of 1.8 meter thick. There is a cushion from here 1.8 meter thick, and we also have what? We also have there is a what between the plate and the between the plate and what between the plane and the plate, and we have what an inclined plane at 30 degrees Celsius. Let's say from an inclined plane of here, having a 30 degree, an inclined plane which is theta. Our here is what theta, which is what 30 degree, and inclined plane to the what to the horizontal with a velocity of what 0.36 meter. That is our use what 0.36 meter per second. So from here, what do we have again? There is a cushion of fluid of 1.8 meter thick between the plane and the plate. Find the viscosity of the fluid if the weight of the plate is 20 Newton. It means we are having a weight of what? Here we have a 20 what Newton, which our force is what 20 Newton. So this is what they are talking about, that here from here we are having what we are having another angle which is what having a weighting of what 40 Newton, and this one is talking about what is talking about the horizontal to the horizontal of what having plane at what 30 degree of horizontal. So from here we got our u, which is our velocity. So we have to find what we have to calculate the viscosity of this. So for us to calculate the viscosity for this, so if you look here, remember in force, whenever we are talking about force, horizontal component for force, we have forces mg sin theta. Remember we are being given an angle. So if it is vertical, we are going to have mg what cos theta. So we are considering what mg sin theta. So it means for us to get our force here, we are going to multiply mg sin theta. Remember our mg we got this from what weight sin theta. So solution for this, given that so what do we have here? A plate having an area of 0.6 now. So we have area as 0.6 meter square is sliding down an inclined plane at 30 degree, an inclined plane of about 30 degree to the horizontal with a velocity of what? We have a velocity. Our velocity is what? Our velocity is what? Du, which is what? 0.36 meter per second. There's a cushion of a fluid 1.8 meter cube. So these are what? Distance. This is what? 1.8 meter square. So we have to convert 1.8 meter square to what? To meter. So we are going to have 1.8 meter square all over what? 1000 meter. Something like this. These are going to cancel. So if you divide 1.8 divided by 1000, we are going to have what? 1.8 divided by 1000. 1.8 divided by 1000. We are going to have 1.8 times 10 raised to power 3. 1.8 times 10 raised to power minus 3. Then, what do we have again? We have what? We have find the viscosity of the fluid. If the what? If the weight of the plate is what? We have been given weight as what? 280 Newton. So for us to calculate our torque, our shear stress, remember that our torque is what? What? Is the force exerted by area. We have force all over what? Area. And I have been given area here. So we have to find the force. And the force exerted on this is what? Is horizontal component, which we have what? Which we have our force is what? Weight sine theta all over what? Area. So our force here we now have our force as what's our weight? We are being given weight as what? 280 Newton. 280 Newton sine what? Theta, which is the angle 30 degree. So what is our sine 30? Sine 30 is what? 0.5. Sine 30 is 0.5. So we have to multiply 280 by what? 0.5. We are going to have 280 times 0.5, which give us 140. Which give us 140 Newton. So our force is what? 140 Newton. Since we have gotten our force here, we are going to have force as 140 all over area, which is what? 0.6. If we divide 140 divided by 0.6, what are we going to have? I will have 233.33 Newton per meter square. So this is from our shearing stress. So according to what Newton laws of viscosity formula, we have mu is equal to shearing stress is equal to mu all over du all over dy. So what's our mu here? We got as well 233.33 is equal to, what is my mu? Mu, I don't have mu. So I'm going to find the what viscosity is. We are not given viscosity. We have to find viscosity. What's my du? My du is what? 0.36. What's my dy? My dy is 1.8 times 10 raised to the power minus 3. So if I cross multiply, I'm going to have 233.33 times 1.8 times 10 raised to the power minus 3 is equal to mu times 0.36. So if I multiply this one by 1.8 times 10 raised to the power minus 3, so I'm going to have 1.8 times 10 raised to the power. I'm going to have 0.419994 is equal to 0.36 mu. I want to get what mu is, so I will divide both sides by what? 0.36. So I'm going to have mu is equal to 0.419994 all over 0.36. If I divide this one by 0.36, I'm going to have what? My mu will now be 1.1665 Newton second per meter square. That is, my viscosity is what? Viscosity is 1.1665 Newton second per meter square. So therefore, the viscosity of the fluid, if the weight plate is 20 meters, is what? 1.1665 Newton per second per meter cube. So this is the solution of the given problem above. So we have gotten our viscosity.